That's cool to go. We're rocking and rolling. And I think we had one extra person that was supposed to be here that couldn't make it. So that means we have an extra 10 minutes. So I'm glad because I got 40 slides. So, yes, sir. There's a question already. We haven't even started.
I am that person.
You're that person. Are you coming? Are you presenting?
My ambition outweighed my talents. No?
Okay.
So I just abandoned my presentation for this day.
I see. You yield your time. I appreciate it. Thank you. Yeah. Hey! Are we good? Yes. All right. So now we get going. So what I'm going to do is I'm going to share with you some insights. Like I'm just a hobbyist. I'm not an engineer, but I've certainly tried this for quite a long time. My buddy Chris was sitting back there. He and I started building mixers and stuff back in Denmark in, what was it, 1974? Long time ago, too long to even remember. So I remember we used to go to junkyards and get old televisions and get soldering lugs out of it and old resistors, right? I remember the first mixer we built, it was just humming like crazy, and we were trying to put in shielding and everything. Now it's gotten a little bit better. So let's take you through. So let's start with the basics. What are we trying to do here? What are we all trying to do? If we're building a speaker, you're really building a motor. It's a motor assembly. Why? Because you have a magnetic field and you have an induced field of electronics, right? Electrons flying through a coil. So these two are actually very, very similar. To what end, you might ask? Well, one powers a Tesla. The other one powers the little air molecules that makes flying possible, that makes hearing possible. If we were sitting in space, we wouldn't be able to hear each other. Is that true? So you look at this, you go, so how have people been doing this for years? They have to create this electromagnetic force. They have to get an amplifier. And that's why we're here, burning amp, right? So we're not going to light this sucker on fire, but we are going to take a look at what does it take to actually do this. And there's one very fundamental problem, and that is Ohm's law. How many here, Ohm's law, you know it well, right? So by the way, I always find this wheel over here very, very confusing. So I grew up, remember Uri Geller? Remember him? So that's how I ended up remembering Ohm's law. U equals R times I, which would you say in Europe, right? But here you say V equals R times I. And once you know that, and then P equals V times I, then you know that P equals R times I squared. And that's really where it gets ugly. Because, as you can see, as we're adding more and more amps to the equation, the number of watts goes up exponentially. So it's actually hard to build something that plays loud. And the more components you put in, the more chance you have of distorting everything you're doing. So if you look at what has happened historically, the first little radios, by the way, you know this, DeForest invented the triode in what is it, 1907? It took 20 years, 2 decades, before all of a sudden we started having talkies. And remember, in those days, they didn't even have the audio on the film. They actually had a little shellac record, very big one, called Vitaphone. That was how you got the jazz singer to work. Now, what happened quickly was the industry got into high gear and they started building amplifiers like this. How many people have seen this one go, yep, I've seen that schematic? Yeah, so half of you, right? So that's the best thing about the internet. You can use that as a research tool. You can find all kinds of schematics, but many times, many of us look at this and go, holy mackerel, I can't make heads and tails of it. And this is really what we're trying to do in this little 30-minute class. So the beginning here to the left, there's the input stage. The middle here is the voltage amplifier stage, and you have the output stage, which is a 300B driving a transformer, and then the speaker comes in. It looks very complex. So I don't know if Herb Reichert is here. He was here last year. He's not here this year. But you all read his articles in Stereophile. Roughly 20 years ago, he actually published this little thing on the internet, and you may have seen this one. It's a simplification of the schematic you just saw. The big difference is we don't use pentos in the front. We use 2 triodes, but we have exactly the same setup. Input stage, driver stage, and output stage being a 300B. Here you get roughly 8 watts. They sound glorious, especially if you have a very efficient speaker like they used to do in the old movie theaters. You have big horn speakers to get this problem solved. Now, there are folks that commercially took this idea, cleaned it up a little bit more, and you end up with something like this. So this you've seen too. Audio note, right? So notice the schematic here is from 1996. So they've been doing this, what, for 20 years ago. There's some here, there's a theme coming here, right? 20 years, 20 years. So this is a classic. See, the only difference here is the 2 triodes don't have a cap between them. And we can argue back and forth, well, that's a bad or a good idea. I need more coming in here, okay? I'll be closer to the mic. I thought you could hear me. I'm always very loud. Yeah. Okay, good. So, perfect. So you start saying, okay, well, that's lovely, but can we start breaking this down a little bit, right? Can we do some circuit analysis? Because when we go to the internet, I need to be able to, at a minute, see, all right, here we have this, and this. I can pick up ideas and learn and start building my own stuff. So let's break it down. So you saw that amplifier, input stage, voltage amplifier, output stage. If we break this down, here's what we typically see. First, 10x amplification on the first one, give and take, 10 on the next, triode, and then the 300B does what? 4. So you go look at that, you go 10 times 4, 400 times amplification. Do we need that? And the answer is, yeah, we do need that because remember, tubes are great at driving voltage. They suck at driving amperage. And you saw from the beginning, if I need wattage, I need amperage. I can't get around it. I need more current. So how do we solve this problem in a good old tube amp that many of you have built? You put a transformer in, and what does the transformer do? It actually takes the high voltage swing, right, plus minus 400 volts, you know, at least 200 volts, and down to like 10 volts or so, or 8 volts, what you need on the output, and you get roughly 10 watts, thereabouts. Now, how do we get beyond this? Well, begin to look at it this way. You say, aha, each step has higher and higher amperage. What if there was a smarter and better way to solve this problem? Because here's what we don't like. See, a lot of folks are sitting around going, yeah, but single-ended triodes sound great. By the way, my wife, she swears by this. Every time I build something new, she always says, can't you put the 300B back in? I'm going, honey, it doesn't play loud enough. And she says, I don't like it to play loud. But here's the interesting thing, we break it down. Okay? Everything comes at a cost, right? Set mastery thinking here. Everything has a cost either way. And you look at this, you go, well, I needed a 20x roughly from the CD player's output or from the DAC output. I need 20x. What about the other 20x? That's actually OF amplification. I've actually spent a lot of extra tube amplification just to get to that swing I needed in the output transformer. What if I can get rid of that? Ah, big idea. And the answer is go back to the first principle. We're running a motor. So if I was building a Tesla, not that I am going to, but my friend here, Chris, he has what, you have 2? You love them, you swear by them, right? It's an electrical motor that's driven by MOSFETs, yes! Indeed, we're using them to drive motors. So wouldn't it be a good idea if we could use MOSFET to drive the speaker? And the answer, of course we can. We could just replace it right there. There's a couple of more refinements. Let me show you this. Actually, it looks like this. What we have typically done is we moved from you see over here, it's a source follower now, right? So it doesn't amplify. The one on the left amplifies, and actually it's a bridge. We don't need a bridge, we just have a bridge, and now we have a perfect current driver. So, with that in hand, you go, yeah, but I looked at a lot of MOSFET amplifiers. This is actually not new. No, it is not. People have been doing this since the late 70s. Here's an early, from the internet again, an early, very simple differential long-tail pair in the input. A VAS here in the middle there. You can see that. I can't point with this, I don't have the driver for it. But here's the point though, you see how simple that is, right? So there are other variations to that. You've seen this one, that's the old Hitachi. They came up with these very nice lateral Hitachi MOSFETs. And here they put 2 in parallel for better current. Long tail pair in the middle, a little more gymnastics there in terms of how they build the driver stage. I actually don't like this schematic that much, and I actually have an amplifier. There's some from New Zealand, and they sound like crap. They need to be warmed up for at least a day before they sound good at all. So this is a little dodgy, but a lot of folks have built this, and they're happy with it, and it actually works. So then a lot of folks like Hafler, right? We saw Bob Cordell's presentation a couple of years ago. He actually started taking apart a Hafler. Did a beautiful job. Here we have symmetrical long-tail pairs in the input. So you begin to see these are variations and themes all the time. Now you go, but I don't want to build a transistor amp. I want to build a hybrid amp. I want the best of the elegance of the tube sound, and then I want the current drive of the MOSFETs. So let's put that together. And here again, here you see it, input. There's a little feedback loop there. You don't like feedback that much, but if you use it sparingly, it's actually not a bad thing, which we'll see in a second. Then the VAS and the output. You begin to see the thing. So how about combining technologies? You want to try that? Well, let's see what we can do here in the lab. Okay, so a thing that comes very obvious is, well, what if I use an input stage, a triode, and I cascade that to another one? Then that gives me roughly 10, that gives me 100 times amplification. That's a little high. But then I run a bias circuit across those two, P and N type in source follow mode, and then I have pretty much the idea for what is this? Very important point, guys. What is this? This is a single-ended amplifier. And you start going, no, it's push-pull. No. Only the output stage is push-pull. See, I read articles that say, oh yeah. So I read an old article about, who did that? There was our friends at MOSFET, right? Remember, they talked about it had a phase inverter inside. They don't, there's no phase inverter in this picture at all. Here again, input, VAS, and output. Begin to see the theme, yeah? So then, here's the old elaborate MOS code. I look at that and go like, yeah, what do you throw in the kitchen sink? They have a couple of crazy ass ideas in here. Like, look at there, you have two seaters here to limit the swing on the input, and they have some crazy stuff. This can be cleaned up a lot. So let's do that. First, let's build a universal MOSFET output. One you can use with any tube configuration you can think of, right? And this turns out to be this one. Here we actually used, there's a 100-watt output here, and that thing works all the time. And by the way, you can steal an old MOSFET to do, sorry, an old half to do that. Here, if you want a little more watts, go a little higher on the voltage and go another output transistor, and we'll see that. We'll use that concept in a second. Now, for those of you who were here a couple of years ago, Nelson Pass, who we know and love, he had a depletion mode. Remember that? Do you guys see that? Depletion mode output. And the reason he said that was actually worth fooling around with was it was super easy, and it was actually built out of parts you can buy from DigiKey. Because the other one, the 2SK 1058 and the 2SJ 162, they're unlimited supply, right? The HITACHI gave them to Renaissance. Renaissance, they don't make them anymore unless you're a big wheeling dealer. If we want to do a group buy, we could probably get some, but they're not commonly available. You can get them on some dodgy eBay listings, but you don't know what you're getting. Sometimes, have you got this where you buy a transistor and the top has been milled down and it has a fake nomenclature on top? You get screwed 5 ways on Sunday, so watch out, right? A lot of gray market. Now this you can buy from DigiKey. Now I actually built this, and I didn't have a chance to take it with me, but this is going to come next year, yeah? So here, by the way, if you built this right now, here's an interesting thing to observe here. See the DC offset? That's an odd way to put that. Here at the top, you see that thing moves up and down, right? Actually, it'll shift the entire stage up and down. And what's so nice about it, which Nelson said, is spot on, and that is, this thing is automatically temperature coefficient correcting. So it turns out that as it heats up, it can sit nicely at 10 millivolts all day long with a smile on its face. So if you want to build a simple hybrid amplifier, I encourage you for this circuit here. You should be able to crank out 100 watts or so just with those two transistors. All right, good. So now let's see a little bit. So you start going, oh, this is a brilliant idea, but have you done this, right? You're talking about it like you've done it, Dennis. So now I'll show you a couple of things I've done. I posted some of them on DUI audio. This one was my first attempt. It's actually a funny one because here all the voltage amplification is happening in the first stage. You can argue that's a dumb idea. But you can see this looks very much like just a SRPP where you take the signal out of the plate of the lower tube and then stick it into a follower circuit with a constant current source, right? Because you have the extra triode anyway, why not, right? So I actually built that. I also decided to build one that was 300B. Why not, right? You can put any tube in you want. If you like the sound of 300B, put that sucker in. And I had that here. Remember that, Chris? We hauled that in here a couple of years ago. What was it, 2014 or something we had it? I put it in a Hafler 505 chassis when I have the fan. That's a bad idea because guess what? You have microphonic tubes. So they hear the fan turn on and go, like, oh, damn, I got to do passive cooling on these MOSFETs. So I learned the hard way there. Here's another one. It gets a little sexier. If you don't like the cathode follower output, you can actually use a plate follower output. This is what we did here. And if you notice what happened here, we actually did have a little bit of amplification. So it has low output impedance in the tube stage. At the front end, the share, notice both 27 kiloohms. It's actually completely balanced in terms of the current it draws as it shares the actual, it shares the coupling down here, 390 ohms and 330 microfarads. Quite nice. Running, you could argue this one runs a little higher than it should. That one runs maybe a little lower, but it actually works pretty well. And I had that at Burning Amp a couple of years ago when we were down here at next to 101. I brought that in and it sounded pretty nice. And what's so fun about this is anyone here can take and buy a rotten old Hafler on eBay and retrofit that to be this. And there's actually room. There's people on the DUI audio says, Dennis, I'm not sure you can fit all that in there. And I want to show you I did it. And actually, yeah. And the fun part was you have to bend these brackets, you know, to have the tubes actually mounted in there. But it works nicely. It looks like a cruddy old Hafler. It doesn't look sexy, but it works and it sounds nice. This was one that won the wife approval factor. She actually liked that. Simplicity wins the day. And here is the latest incarnation of this idea, okay? And this is, here we're actually taking the, see this is a plate follower circuit like you saw before, but here we're taking the feedback from the plate follower where there's a voltage splitter, we're taking that from the output. What's the benefit of doing that? Oh, any back EMF that's coming from the speaker back, we actually let that driver tube compensate for it. It gives you better damping factor, better bass. Here's what's really nice about it. It's not global feedback. It's local feedback because remember, the MOSFETs here are not amplifying. This guy's the only guy amplifying. So this is actually a modified plate follower circuit with the speakers in the loop. Very, very nice, and I like this circuit an awful lot. So you said, Dennis, you talk about 1927, the 30s. You talk about the 70s, where we did all the MOSFETs. Did you forget the 50s? And I'm going, yeah, sort of save that for last. Because you look at the 50s, what was the sexy part in the 50s? People started, remember there's fashion in this industry, right? So people started looking at this going, we don't like single-ended. Single-ended sucks, it's inefficient, right? What we're gonna do instead is we're gonna use, ta-da, push-pull, right? And then people got nuts. This is the reason this is an important observation in our journey here, is this the first time we actually do have a phase inverter. Here we have a split load phase inverter, that's the second tube in here, and then we have two drivers, and then we have the output stage, yeah? Classic circuit. I built this, by the way, doesn't sound that great. Lots of loop feedback, it sounds like average 50 stuff. Doesn't sound too good. If you want to build that kind of amplifier, the MULLARD circuit is by far a better one. Why? Because the long tail pair here sounds a lot simpler, a lot better, a lot cleaner, a lot more human. With voices come across beautifully here. I did not use, like here, a penfield in the input. I used a triode in the input. You can build a similar circuit and triode couple the EL34s. Got a beautiful 12-watt amplifier. Okay. So now you go, okay, so we got the whole thing. We got the way we used to build amplifiers with triodes, the way we can actually use tubes in the front and current being driven by MOSFETs, thanks to the innovations in the 70s and 80s. So can we now start building this all into what we would do today? I mean, what would we do in 2019? And the answer is we've got to take this to the next level. So here we've got to give you a quick turn and then I'll shut up and then open for questions. So here, balanced input. What if I had balanced input and I hit them right into a long tail pair? Then they're 100% symmetrical, it's 100% symmetrical, right? There's no phase splitting. You could turn this into a phase splitter, you'll see that in a second. And then we have the two, remember I said there's local feedback on the two other schematics you saw, plate follower. Here the plate follower is all the way out, but now we're running true push-pull. If you look at a tube amplifier, the push-pull is happening through the primary and secondary and the output transformer, right? They are actually pushing and pulling. So if you want to build a push-pull amplifier, this is kind of a block diagram. Let me show you how we built this. A lot of fun. So here's the input stage. There's a nice little feature here that you'll appreciate. See, there's a switch there that says, oh, I guess the font there had moved over a little bit. No worries. It says balanced and single, right? If it's up high, it's actually balanced. It shorts out that 7.5K resistor. That means now the long tail pair is 100% balanced. Signal comes in 100% balanced. And then when you go single-ended, right? Because there's a single-ended input. If you don't have a balanced DAC, then it actually adds the 7.5K to the long tail pair, which reestablishes the balance that you actually wouldn't have had if you didn't have a balanced signal. I looked at the scope, it looks absolutely mirror image, it looks absolutely beautiful. So that works. What do we drive this with? Well, if we're doing push-pull, we need two power modules. So here they are. Here we had an extra triode laying around, so we just did a cathode follower just to get a little better rise time on the MOSFETs here, because there is a capacitance sitting at the gate of each of these suckers. So we had it. You can argue, you don't like the quality, you could have put a plate follower in there if you wanted to. You can do all kinds of fun stuff. That's the whole idea. You're cooking with tubes. Like it was like a little salt, a little garlic, you put stuff in, right? The way you like it, right? It's a musical instrument that you do for your amusement, not anyone else's, yeah? So this is your output stage. Now, let's talk and look at how we actually build these bad boys. And because we talked about depletion mode and we talked about Nelson, I'm sorry, Nelson, if he would sell the boxes, I would buy the boxes from him. But do you guys do that? You don't do that, do you?
No, and you guys can probably get the boxes built as cheaply as we can.
Cheaper from China, yeah. So I did that, but it was sort of a hat off to all of the stuff I learned from you guys that I decided, well, I want to see, instead of looking at a rotten old Halfer, people look at it in my house, they come, what's that? That looks like something should be in a junkyard. I decided, well, this will look a little nicer. So I got inspired by those Chinese rip-offs of half the design, which I really think is neat. So let me show you how we built this. So here's actually a nice little tip. You want to do point-to-point wiring. But what you want to do is point-to-point wiring with the ease of a printed circuit board. Now, who else does that? Again, we're borrowing from all the other people in the industry. Audio Note. There's a great video on YouTube about how the Audio Note, people are sitting there very meticulously, point-to-point wiring. What they're doing is they're building a custom board, a passive board, and then they drill the holes so they fit the components, and then they just thread the little leads through the board and actually solder them at the back, and that's what you see on the point-to-point wiring. This is the same board you see on the right here. That's just the piece you can't see when it's mounted inside the enclosure. Whoops. What happened? That wasn't me, was it? There it is. Okay, so the 4 sides, here are the 4 sides. We need a little mounting bracket, so we have an L bracket here where we have 6 MOSFETs mounted, and the tube then sits into driver tubes naturally. It sits into a form follow function. We have the driver tube sitting right next to it. And as you can see here, the little brown guys there, they're actually Russian point-to-point soldering lugs. They're really heavy duty, and I like them. Only one thing, if you use them, you can buy them very inexpensively on eBay. Make sure you use a little file and clean them before you solder them, because they've been oxidizing so much that they don't solder easy. But once you do that, they're actually quite beautiful. Here you see in the middle, testing it, you can't really see it, but it says 0.05 volts there. We are testing the offset that's actually being measured on that module itself. So we built 4 modules exactly the same, and now you have 4 amplifiers essentially that you need to integrate in 2 enclosures, right? 100% symmetrical. So you do that, and this is what's happening there. You can see my shop is very, not a mess there, right? My wife says, I read somewhere that creative people have very messy desks. I go, keep reading that, honey, keep reading it. Because my office looks like someone's shirt. All right, so here you go. Here are the monsters. They're built. We brought them. That's why I'm sweating. We huffed and puffed all the way up. Chris helped me. And we have them over there at the display, and you can listen to them. So with that, I hope that helped a little bit, gave you some ideas. So with that, happy building and have fun here at Burning Edge. Thank you, guys. Questions? Yes, sir.
What do you have driving?
What have I?
What do you have driving?
What driving? Oh, some 86 per dB watt meter speakers, 3-way speakers. I have them over there. Just my home speakers. I was going to build some speakers, frankly, and I looked on eBay. Some guy in Canada was selling some Arum Cantus speakers that evidently he closed out. It was $1,200 for a pair. I'm like, I can't even build it for that. So I bought the first pair, and my wife goes, oh, do we have to spend that money? Then I bought the second pair, and then she got pissed. But they've been my go-to speakers for a while. They have it's actually funny, they have a ribbon tweeter, you know, they see them all the time. And the ribbons, have you had this experience? After playing a little while, the ribbons, they disintegrate. So I'm gonna give you a tip. Toblerone is the tip. That little piece of foil that's around the Toblerone bar, you clean that out with a little rag, a little soap, and clean it out on the glass plate, cut it with an X-Acto knife, right? And then you just bevel them on top of something that has a coarse surface, and then you put them in, and they will never die on you. Although I will say, I was looking at it yesterday, it looks pretty bad. One of them is beginning to get a little, but I have plenty of Toblerone stashed, let me tell you. So yeah, that's a great speaker. I'm a big fan of, I'm actually going to build some coaxial ones, but I haven't done the woodwork done yet, but that'll be 96 per dB watt meter. That'll blow the roof off the house.
Yes.
Yeah.
And they smell like chocolate when they play.
Yeah, that's right. You'll get hungry when they play. Yes, sir.
Is the presentation available online?
Yeah, I'll be happy to post it. I'll send it up there.
All right.
That's great. Yes?
Hey, Dennis, have you compared the counterpoint hybrid?
Yes, I have 2 of them.
How they're different?
Yeah. So the counterpoint ones, they use some very strange MOSFETs that are very, very brittle. And when you buy one on eBay, the MOSFETs are typically blown. What I like to do is I like to use the Hexacon MOSFETs, then I redo the bias circuit, and then they actually play very nicely. I don't like the driver circuit, I really don't. The tubes are 60J6s in there. What is it, 60J? What is it, 7, 9, 9? Right, the classic standard preamp tube, right? So you have to change a couple of values around, but you can actually take that, use that as a card, because you don't even have to jug the good old board. You can just cut a few traces and rewire it, and it's nice. I will tell you this, if you buy one that's completely junked, you can build yourself a brand new driver board in there and just use the case. I mean, the counterpoints they did a great job. I also have 2 Moscows that I bought on eBay, and you know what's funny about the Moscows? I'll tell you this. I was playing with them. They had great bass, right? So I'm playing when I'm looking at the bass driver, there's this weird overhang that's happening. I'm going like, I bet it's because those guys used loop feedback. And they did, right? So you look at how many, they have 2 triodes after each other, and then they have a white cathode follower to drive them. You don't need a white cathode follower to drive MOSFETs, because MOSFET has a very, very high input impedance. It was like, they didn't quite know what they were doing, but they managed to muddle through somehow. And it's not a bad amplifier, it just, you can build something better yourself by making it simpler. Yeah.
Burn your house down.
No, I tell you what though, I was fooling around with it. And you know how it is, you're tired, you don't pay attention. So I'm sitting there trying to measure the output on them, and I shorted the output on them while I was running 36 volts on the outputs, right? And that's like 150 volts, 150 watts, sorry, 150 watts. So I tried that, and it went, and you can see a spark come off the binding post. Of course, it took my fuses out. But here's a cool thing, so there's a little tip for you. So if you're a butterfinger like I am, and you screw up, you get tired, you had a little tequila too many, right? This happens in my house all the time. So I'll tell you, it puts some fuses in so that the fuses actually are going to go. And I tell you what, here's a rule of thumb: 1 amp per MOSFET pair. So if you have three pairs, 3 amps. Then it probably will survive. Yes. Quick, I think my time's almost up. But one last question. Yes, sir.
Little question. Years ago, I had a great triode preamp, and I got rid of it when I could no longer get good 6 SN7s, and I saw those all over your schematics. There must be good ones available again.
Yes.
Is that true?
Yes. I'm very glad you asked that question. So I actually don't think that the electro harmonics, I think, sound pretty decent. Right? I don't think they've gotten a gun. If you go get the surplus ones from Russia, you can buy my whole bag, $2 a piece. They sound like crap, but they're great for testing, okay? But the electro harmonics, they're very nicely built tubes. I tried the tone sol ones, which are the electro harmonics, but they sort of got the tone sol brain. They sound a little dark to me, so I didn't necessarily like them that much. My wife likes them because she doesn't like things that sound sharp and edgy. I will tell you, I also tried the CV181s, I think they're called, the ones from China with the bulb. They look very nice in this bulbous envelope. And I was surprised how good they sounded, but they all sound different, you see. But yes, you can find tubes that actually might be to your liking. And that's of course why people like tube rolling so much, right? And you can buy cruddy ones on eBay and roll the dice, you know. Sometimes Etsy, I found out, you know, that you can go over there. They don't know what they're cleaning up from Grandpa's garage. They have no idea. The guys on eBay, they're a little too smart, right? So you go over there, you buy a bag of variant tubes, you go, oh, there's 2 almost brand new RCA 607s from the 50s. They sound very smoky, very sort of Chesterfield cigar smoking, cognac. Yeah, I'll tell you. So yeah, so I would say there's hope because there's such a surplus, and all you need is 2 good ones, right? So yeah.
I found they lasted about 6 months in my preamp, and the ones I loved were old government surplus radar tubes.
Yes.
And when those were gone, I just got rid of the preamp.
Yeah, I think if you're a little more bold, you can probably compensate a modern tube by picking maybe different load resistors. I tried a single-ended 300B amplifier early on, just like 15 years ago, and I basically went and said, yeah, well, can we hear the difference, right? And I talked to an engineer friend of mine, and he goes, "You're crazy, Vilfort. You can't hear the damn difference." I go, "Well, I beg to differ. I try everything. I tried Carbon Comp. I tried Alan Bradley. I tried metal film, right? I tried wire wound non-inductive. I tried wire wound inductive. I can tell you, actually, wire wound inductive, those little white cement resistors, for the money, they sounded pretty good. So if you're a little handy with the soldering iron, you might actually be able to compensate some of the things you don't like by using a modern tube. All right, I think my time is out. Thank you so much for your attention. I enjoyed it.